learners. Today we are going to study about radicals and surds. We have the square root, cube root, fourth root, or any kind of root. This symbol is called the radical sign. The number or letter inside this radical sign is called the radicand. And the number here is called index of the root. If there is no number there, it is 2, meaning it is square root. This square root of 5, if you have cube root, you have to write the 3 there. If that is fourth root, you have to write the 4, fifth root, sixth root, seventh root, eighth root. You have to write the index of the root there. For 2 or square root, you don't need to write the 2 there. It is understood to be a 2 or a square root. Now, this one is in radical form. In exponential form, this one is 5, the radicand, and the index of the root is the denominator of the exponent. The one here is actually 5 to the first. If that is 3 over 2, so we have 5 cubed. Letter A raised to the 1 over n. You see here that the denominator of the exponent n becomes the index of the root. A now is the radicand. So example, we have 27 raised to the 1/3. So when you write this one in radical form, we have the 3 as index of the root of 27, and this is now cube root of 27. If you will not write here the 3, it will become square root of 27. So you have to write the 3, 4, 5, 6. So this one, we know this one is 3. Cube root of 27 is 3. Because 3 times 3 is 9 times 3 is 27. Okay, this is another concept. If this one is cube 3, now we can change 27 to 3 raised to the 3rd power. When we have the same index of the root and exponent of the radicand, we can cancel the 3 here and the 3 here. So what remains is only the 3, which is our answer. If this one is square root, this one is 2, then we have 9 only, because 9 can be written as 3 squared. We have the 2 here, we have the 2 here, we cancel that one, and we have the answer 3, because 3 times 3 is 9. So just always remember this concept, because we are going to use this concept later in our lesson. Letter B, we have index of the root, maybe square root, cube root, or fourth root, and then we have A times B. Index of the root, maybe square root of A, square root of B, cube root of A, cube root of B. We can separate them. So for example, we have, let's have square root of 20 here. Okay. Square root of 20 can be broken into 4 and 5. And make sure that one of the numbers here is perfect square number, meaning we have 4, 9, 16, 25. Any number that has a square root, then break that one. So we have 4 and 5. 5 is not a perfect square number, only 4. So this 4 times 5 can be written as square root of 4 and square root of 5. Then you take the square root of 4, which is 2, the square root of 5. So our answer is this one. Now, when writing or when we simplify radicals, I recommend to use this form instead of this form. Our index of the root here, and we have the index of the root, which is different from the index of the root here. So, and have the radicand here. If you have index here, and that's inside another index of the root, we multiply the indices here. So we have m times n or mn, and we have the radicand p. Example, we have cube root of 64, and then we have the square root. So this one is the square root of the cube root of 64. But what is the number here? So the number here is 2, because we don't see any number there. That is square root. Now we can write this one as 64 here, and then 2 times 3. So this one is to the 6th. So here, if we are going to solve here, we have the square root, and the cube root of 64 is 4. 4 times 4, 16 times 4 is 64. Therefore, here is square root of 4. And what is the square root of 4? That is equal to 2. Now, if we have this one here, right here, we can write this one using that concept. So we have 64, and this one is 6. We can write this one 2 to the 6th. We can write our 64 to 2 to the 6th. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2 is 64. So 2 to the 6 is 64. When you have the 6 here, index of the root, and you have the exponent here, 6, we can cancel that one, and what remains is this 2 here, which is the same as our answer here. Okay, let's have some examples of our concept. We have 64 raised to the 1 over 12. Okay, now we have 64, and can we write 64 to the base 2? If we have 27, 81, 243, we have base 3. So we know this one is base 2. So we have 64, and for 64, don't mind the 1 over 12. Okay, so we will write 64 as 2. The base is 2 raised to what? To get the 64. So you have 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2 is 64. So this one is 6, and then raised to the 1 over 12. And what do we do with exponent to exponent? We multiply. So this one is actually 6 times 1 is 6 over 12, and then that 2, 6 over 12, lowest term of 6 over 12 is 2 to the 1/2. And 2 to the 1/2 is, in radical form, is square root of 2. Here, if you have square root of 3 over 4, you can separate them. You can write the square root of 3 here alone, and you have the square root of 4 alone. If you have the square root of 3 divided by the square root of 4, you can combine them, and then you can divide. You can divide first before you take the root. So here, square root of 3 is still 3. You can take the square root of 4, which is 2. Okay. What about this one? So the shortcut here is, if this one can have our root, then this one will be a square root, and the cube root of 8 is 2. Because 2 times 2 is 4 times 2 is 8. That's cube root of 8. Or we can write this one as 3 times 2 is 6, and then this one is 8, still 8. We multiply 3 times 2 is 6. Then this one can be written as, this one is 6, and you can write this one as 2 to the 3rd power. So 2 times 2, 4 times 2 is 8. So you have 6, 3. And then in exponential form, we have 2, 3 over 6. And this one, the lowest term of 3 over 6 is 1 half. And that one is also square root of 2.